Amplification means making sound louder. If you want to make the sound louder, you amplify. You can use amplify. Then we have these two common words which are very common in the exam. Pitch. This is the highness or lowness of a sound. Pitch is the highness or lowness of a sound. Most when we talk about pitch, we refer to the stringed instruments, whereby we say pitch depends on a number of things, either the tightness or looseness of the strings, the shortness of the wire, and many more. Then we have volume, loudness or softness of a sound. This one mostly depends on the force applied. The next type of energy, the last type of energy, is mechanical energy. And if I take you back in our first subtopic, in the topic energy, we talked about two main kinds of energy. We are going to say now, we have two main kinds of energy, that is potential. Then we have kinetic. We said potential energy is stored energy and no work is done until the object is released. Then kinetic energy, this one simply means moving energy. When you look at mechanical energy, this is energy due to these two types of energy combined together. So it's energy due to total kinetic and potential energy. Energy due to total kinetic and potential energy. Then we have these examples which possess mechanical energy, whereby you find for them to operate, these two energies should come together. We have rotating turbines. We also have the bicycle dynamo, car engines. We have rotating windmill. We also have a hammer striking a nail, a magnet attracting a nail, and generators. And when you look at the picture we have here, these are turbines. As you can see, these are turbines. They are not moving. And I've just said, mechanical energy is energy due to potential and the kinetic. So these turbines now, when they are not moving, they have potential energy. So these turbines can move. They can either be meant to move by either steam or water or moving air. So as they are now, they are stationary. They have potential energy. But now, if now steam starts moving them now, the energy changes and it becomes mechanical energy, because we have two energy coming together. These are the windmills. Windmills, we also have said they possess mechanical energy. As they are, all of them now, they are not moving. There is no wind. So they have potential energy. So if wind starts moving them, because now the wind will have kinetic energy as it comes to make them start moving. So now the energy changes. It is now potential, then wind starts blowing, whereby the wind will have kinetic energy. It starts moving them round. The energy changes and it becomes mechanical energy. We also have generators. All generators, they possess mechanical energy. These are examples of generators. We have this big one. We also have a generator in our school. Those who have observed next to the gate there's a generator there. We also have these generators. Also, some have generators at their homes. So all generators, they possess mechanical energy. We also have another example, hammer striking a nail. So as you can observe, this man is holding the hammer. The nail is placed here. So the nail has potential energy. But the moment the man drops the hammer, it means now the hammer has kinetic energy. So they meet and it becomes mechanical energy. As you can observe here, I have the nail and I have the hammer. So if I place the nail there, the nail is not moving. The nail has potential energy. But when I start moving the hammer, as the hammer moves, because kinetic energy is energy in motion. As the hammer moves, as I move the hammer to strike on the nail, it changes. So the nail will remain there, it is stationary, potential energy, but the hammer moves down, it has kinetic energy. So as I strike the nail, there is mechanical energy. That is why you can see now, because energy is the ability to do work. As I strike the nail can be able to sink down the table. Then we also have the last example of the mechanical energy. We have the bicycle dynamo. We learned about dynamos in class 7. This is the rear wheel or the back wheel of a bicycle. This bicycle dynamo is normally placed at the back wheel. Then you realize now, this bicycle dynamo is fixed. As you can see, it is fixed on this metal here. It is not moving, and there is no any single time it moves. So when the bicycle starts moving, because this bicycle dynamo, it is next to the wheel, this wheel starts moving round. The wheel touches the bicycle dynamo. The bicycle dynamo is fixed, it does not move. So the wheel moves around. So it means now, the bicycle dynamo, it has the potential energy. Then as the wheel rotates, it has kinetic energy. So they combine and they form what we call mechanical energy. So that is the last type of energy in our class. Then you realize now, this topic energy is very much tested in the exam. We have a number of questions which can be tested in this topic, and I want us to look at a number of them, so that as we continue with the topic, you can be familiar with what to be expecting in the exam as far as this topic is concerned. So we have some questions, and as I normally advise you, science questions are very simple, but a good scientist or a good student, for you to answer the questions, you have to be very keen. And I told you, before you answer the question, you read it until you understand. If possible, answer the question after the third reading. We won't do the 3 readings here, we will only do it once. But when you're answering the questions during exam time, you have to read them 3 times. The first time, read the question, go through all the choices. The brain is open. The second time, read the question, go through the choices, and that time you are eliminating. You know which one is which. In the third time now, you are trying to make sure your answer is correct. Our question number 1, it reads as follows. Which one of the following substances does not contain chemical energy? Which one of the following substances does not contain chemical energy? And just to take it back, because some learners, forgetting is their hobby. When we talk about chemical energy, we listed the substances which we can say contain chemical energy. The first one we talked about foods. All foods. You have the examples of foods. We are told someone took rice, another one took chapati, another one took soda, that's also food, another one took porridge. It is food, it has chemical energy. We also have fuels, and we have just said the examples of the fuels, things like paraffin, petrol, all those ones are fuels. We also have dry cells. We have batteries, and the last one is chemicals themselves. So these are the substances which contain chemical energy. So when you look at our choices, you want to look the one which does not. So you find fuels, they are here. So this one put a tick, a small tick. Move to dynamos. They are not dynamos here. So this one put an X. The other one moved to food. Food is here. Put a tick. Then car batteries are there. Put a tick. Then you have also read again and confirm. Then you should also be sure, because this one has chemical energy. What about dynamo? We have just talked about bicycle dynamo, and whereby we have said the bicycle dynamo has mechanical energy. So automatically this one becomes our answer. Dynamos, they do not contain chemical energy, instead they have mechanical energy. Question number 2. The following are uses of light, except we also discussed about light energy, and I would say because now energy is ability to do what light has uses. It is an energy. It can be used in a number of activities. So these are choices. We have communication, choice A, warming, photosynthesis, and making vitamin D. We start with A and see whether communication is a use of light. Communication is a use of light, especially in traffic lights. Traffic lights can be used to communicate. Like when the light turns red, there's that information or the signal it gives to the road users. That is the cyclists, the motorists, and the pedestrians.